Hello, this is Mr. Molo for lesson 2-9, 2-10, scientific notation and powers and exponents. So this is going to be another 2-day lesson. The powers and exponents should be a review. We did this with 6th grade lesson, so just going over it again quickly for the 7th grade lesson. Remember, this is our exponent, so we have a base, we have an exponent, and what this really means is 3 times 3 times 3 times 3 times 3, not just 3 times 5. So if we see some examples here, kind of the same thing here. This would be 2 times 2 times 2 times 2 times 2 times 2. So you get a way different answer than just 2 times 6. And then you could also go backwards and rewrite it again. So instead of saying 4 times 4 times 4 times 4 times 4, you could just say 4 to the 5th power. So we're kind of shortening up some things that we're writing. And you'll see that's why we kind of do things with scientific notation as well. And then we have to remember some words here. So remember 4 squared would mean 4 to the 2nd power. 8 cubed would mean 8 to the 3rd power. Or we can just write 2 to the 6th power, which just means 2 to the 6th power. And then going down to our next, so 4 to the 3rd power would be 4 times 4 times 4. 4 times 4 is 16. And then the value of that would be 4 times 4 is 16. 16 times 4 is 64. And then kind of rewriting it backwards. So I have a 3, 3, 3, 3. So that would be 3 to the 4th power. And then 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. I don't think we did this with our 6th grade curriculum, but we're going to be doing it now for 7th grade. So 3 to the 3/4 to the 3rd power looks like it's going to be something difficult, but you really just break it down. So 3 to the 3rd power, 3 times 3 is 9, times 3 is 27. So this would be 27 over, and then 4 times 4 is 16. 16 times 4 is 64. So it would just be 27 over 64. You're just breaking it apart. 6 to the negative 3rd power, we're just going to figure out what 6 to the 3rd power is, and then it's just going to be that as a fraction, so 1 over that is. So 6 times 6 is 36, and 36 times 6 is 216, so it's really just 1 over 216. And then we can kind of see here, we can do 8 squared can give you 64, 5 to the 3rd power can give you 125, so just some examples of how there could be more than one way to get to these answers. All right, and the new part for the lesson is scientific notation. Scientific notation is just another way to write really big numbers or really small numbers without writing all those digits and all those zeros and things like that. So the big rule with scientific notation is this first number, this C, has to be a number between 1 and 10. It cannot be over 10. I know on MCAs they'll say, how would you write this 7 billion number? Well, if they write like 70 times 10 to the 4th power, well, you know that's not going to be right because 70 isn't between 1 and 10. And so kind of just like with graphing, so I see 3.78 times 10 to the 6th power. Well, that's a positive 6, so I'm going to be moving that decimal over 6 spots to the right. So I'm going to be sliding it 6 spots to the right to reveal some more zeros there. So I'm not going to add 6 zeros. I'm just going to be moving that decimal over 6 spots. So in this case, I'd really only be adding 4 zeros. So instead of saying 3,780,000, I can say 3.78 times 10 to the 6th. And that's exactly the same thing. Same thing here. So now I have a negative number. I'm not just going to be putting 7 zeros in front of that 1. I'm going to be moving the decimal over 7 spots. So it's going to look like this. And then our final answer would be that number. And then here's just some more examples. So this could be an example of scientific notation. It follows all the rules. It's between 1 and 10. Here's another one that's good for scientific notation. Follows all the rules between 1 and 10. 5 is between 1 and 10. Here's one that's not going to work. 45.9 is not between 1 and 10. That's going to go in the garbage. 3.214, that's between 1 and 10. 12, not between 1 and 10. Garbage. 10.3, not between 1 and 10. Going in the garbage. 6.09, that's a good one. It's between 1 and 10. Negative 78.3 is not between 1 and 10. Garbage. 1.9 is good, and 4.89 is good. And then we might have to write some problems backwards. So we see here, instead of writing that really big number that Mr. Muller doesn't even know how to say, we're going to put a decimal right here, because that's the only spot my decimal can go, because of where it has to, since the decimal has to be between 1 and 10. So I move my star right here to where my decimal can go. So instead of saying that big long number, I can say 1.23, and then I would figure out how many times I'd move that decimal. So I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I could say 1.23 times 10 to the 11th power. Let's do this one, 9,000, because that's a little easier because we know how to say this. So instead of saying 9,000, my decimal would go there instead of at the end. So instead of saying 9,000, I could say 9 times 10 to the 1, 2, 3, so third power. That would be the same as saying 9,000. And then here's just some more examples. So 7.82, I'd move the decimal over 3 spots since it's a positive 3. So 3 spots to the right, so 1, 2, 3. So 7.82 times 10 to the third would become 7,820. And then we would keep going on with these, and then it has the opposite effect with these negative numbers. So instead of saying 0.000000034, I could say, well, there's my decimal, it has to go between 3 and 4. I could say 3.4 times 10 to the negative, because now I'm moving the decimal to the left, 1, 2, 3, 4, 5, 6, 7, 8. So I could say 3.4 times 10 to the negative 8 instead. Let's do this one as the last one since we know it's smaller. So instead of saying 0.007, I could say 7, and my decimal goes right here after the 7. And then I'm moving it 1, 2, 3 spots. So I could say 7 times 10 to the negative third power, and that would give me the same answer.